Hello everyone. In this section we're going to look at the quadratic functions and their graphs. We're going to learn how to graph the general form of quadratic functions. Now we will be looking at some basic examples that's actually in the book. I'm going to go over these exercises, well, not really exercises, but the examples that are in the book and explain how we're going to graph these. So initially we're going to take a look at graphing these quadratic functions by plotting points. That is by letting x assume a value and defining the y that corresponds with x, and then plot the points. But ultimately the way we want to graph quadratic functions in this section is by the method of transformations. The method of transformation is easy, simple, and effective way of graphing these quadratic functions. And by the time we get through the section, we will be able to look at a quadratic function and be able to graph it without plotting a single point. Again, that's the whole idea of the section, is to be able to graph these without plotting a single point. So let's proceed and see how this is going to turn out. So we are on page 734 of your textbooks, quadratic functions and their graphs. That's where our focus is. Now, initially what we're going to look at is we're going to take a look at the graph of functions, quadratic functions, that are in the form of f of x equal ax squared. A here is a constant in front of x squared. Now, the graph of x squared, which is what's being graphed here for now, right in here, down here, this is the graph of x squared. X squared is the simplest form of a quadratic function that we can possibly imagine. And that's the form ax squared, where a is 1. So again, we could not get a function to be easier than that. So we're going to choose some selective points for x, -3, -2, -1, 0, 1, 2, 3. And then we're going to plug these numbers in for x squared into the function. So -3 squared becomes 9, -2 squared 4, and so on and so forth. And each of these will result in an ordered pair, which we can then graph. So -3, 9 would be 1 point on the graph of this quadratic function. The name of the graph, by the way, the name of the graph is called a parabola. And that's what the name of the graph is. Now, as you can see this graph, and let me possibly put the name down here for you. And let's see. There you go. And let me get my pen going. Okay. So the name of the graph again is going to be a parabola. And these parabolas were discovered by not just parabolas, but in general the conic sections, which will be the subject of chapter 13 when we study. These were initially discovered, these graphs were discovered by Apollonius of Perga. So we'll talk more about that in chapter 13. But for now, we just want to name the graph of this quadratic function. So again, the name is called parabola. That's the name of the graph. Okay. And let's see. So this is going to be what we call now the basic parabola. Okay, so the basic parabola for us is going to be the parabola that actually is in simplest form. That's going to be our basic parabola. So I'm going to write that also. The graph of this function, the function is again f of x equal x squared. This is what we call a basic parabola. That means the most simplest form of the quadratic function. Okay, and let's move on to our next page. So what we want to do in our next page now is the following. In our next page, we're going to actually take a look at now some variation of f of x equal x squared. So in this example, we are looking at actually the graph of 1/2 x squared. That's what this is, 1/2 x squared. So again, we're going to plug these values for x, -3, -2, -1, and so on. We're going to plug it into the function x squared. And for example, when you plug -3, you square it, becomes 9 times 1/2 makes 9/2. At -2, you square, becomes 4 times 1/2 makes 2, so on and so forth. So down here, for example, at 3 squared is 9 times 1/2 again is 9/2. And then we can plot these ordered pairs just like we did the other ones. So our first ordered pairs are going to be -3 and 9/2. And that's going to be like here, and -9/2 is going to be right about here. Okay, so by connecting these points, you're going to actually get the parabola that's on the outside. And then we're going to take a look at the case where we have 2x squared. This is a whole different parabola. So this time again, the same points, -3, -2, and so on. You plug them in. This time a -3 squared becomes 9. 9 times 2 makes 18. As 0, for example, 0 squared is 0 times 2 makes 0. And again, by plotting these ordered pairs, we'll be able to graph this other parabola, which is in blue here. That's this one. Now, the one curve that's in the middle, this one, that's going to be the basic parabola for us. Okay, so I'm going to actually do that one. Let me do this one for you. So the one that we're actually looking at is this one up here. This one, the curve that's in the middle, that's just your x squared. Remember, this is what we call our basic parabola. So what we want to do is we want to investigate, we want to explore the effect of a number before x squared. So in the first example where we have 1/2 right in here, this one where we have 1/2, this number 1/2 is going to be less than 1, but a positive number. So the effect of 1/2, and this would be the graph of it. It looks like as if the parabola, the basic parabola that is, the one in the middle, is now wider than the basic parabola. The new one, the 1/2 x squared, this one is wider than the basic parabola. And if you look at 2x squared, that's the one in blue. So that is, let's say, this one. That's going to be the graph of 2x squared. Now this one looks like it's narrower than the basic parabola. So a number between 0 and 1 makes the parabola flatter around the vertex. It gives it that widening effect. And a number that's greater than 1, such as 2, 3, 1.5, 1.2, whatever. All of these numbers will cause the graph of the parabola to be narrower around the vertex, and that's what this one is. Now this widening and narrowing effect, some call the widening effect as a compression of the basic parabola, and they also call this narrowing effect of the parabola as a vertical stretch of the parabola. And that's what we're going to see in the next section. So let me X out of this one, and we're going to go to the next section. Oh, before we actually move on to the next page, not next section, sorry, I'm going to show you the case where the number in front of x squared, this number in front of x squared, is going to be negative. So that's this one right in here. So if you note here, the number is negative 1/2 x squared this time. So for this one, let me again show you. Sorry. So this is going to be negative 1/2 x squared. That's the graph that you see. Again, same points. You let x be -3, -2, -1, 0, 1, 2, 3. Plug it in. So -3 squared is 9 times -1/2 is now -9/2. At 2, for example, you square it, becomes 4. 4 times -1/2 makes -2. So you can plot these ordered pairs. So for example, this point here, this one, is the ordered pair that corresponds with when x is -3 and y is -9/2. So that's what this one is. This one, of course, is a 0, 0. The 0, 0 doesn't change. Now, in general, what we can see, what the effect of a negative in front, that is this number right here is negative. So the effect of that negative in front of x squared causes a reflection, and that's what we have here. You see that clear reflection? That's because of the negative in front of that x squared. And of course, the 1/2 will give it the widening effect that we saw earlier. Okay. And with that, we can now summarize actually the effects of a number in front of x squared. And that would be right in here on page 736 of your textbook. So to summarize, the effect of a in front of x squared. If this number a is positive, the parabola will open upward. So we're looking at this statement here. Remember, this is just for f of x equal ax squared. If a is positive, the parabola is going to open upward. If a is negative, the parabola opens downward. Remember, that's because the negative number caused the reflection about the x-axis. Now, absolute value of a, because if we have a number such as -2, we think of two effects in a negative number. The -2, for example, the negative part of that number, -2, causes a reflection about the x-axis. And then if you look at just the 2 without the negative sign, that is why we look at the absolute value in this statement here, that number 2, ignoring the sign, is greater than 1. So that means the parabola is going to be narrower than the basic parabola. Remember, everything is in comparison to the basic parabola. That's what we would like to consider for our base case. Now, the number between 0, 1, ignoring the sign, if that number is a fraction, for example, between 0, 1 or a decimal, or any kind of a number between 0, 1, then the effect is to cause the basic parabola to be wider than the basic parabola. The new parabola will be wider than the basic. And that concludes the effect of a in front of x squared. Now, next we're going to look at, right down here, we're looking at the case where we have not only a, but we have x minus h squared. Now, it's very important that we maintain the negative in here. See that sign, negative sign here? It has to be a negative. Only when this is negative, we look at h, and then we're going to look at the effect of h. H is a number, a constant. We're going to look at the effect of h on this basic parabola, and let's see what happens to it. So now I'm going to go on to the next page. And here's an example of x minus h squared. So we're going to look at the graph of x minus 3 squared, this one. Now, for x minus 3 squared, again, the authors have picked these random numbers for x, the random numbers for x, -1, 0, 1, 2, 3, 4, 5, 6, and then they have plugged these numbers in for x. So for instance, -1 for x, that makes -1 minus 3, and -4, you square it, becomes 16. And then you plug in a 3, for instance, 3 minus 3 is 0, 0 squared will be 0. If you plug in a 5, 5 minus 3 would be 2, 2 squared is 4. So you get these ordered pairs now. So the ordered pair coming from this combination here is going to be, that's the ordered pair coming here, it's going to be 5, 4. So that 5, 4 now is going to be right here. That's the point that corresponds with that ordered pair 5, 4. And notice what the authors have done. The dotted graph, the dotted one, that's the basic parabola. Okay, so this one, the dotted one, is x squared. And what they're trying to show is this. They want to show the effect of the 3 here on the basic parabola. Now remember, h is 3 here. That's why we have the minus as part of the form that we're working with. So 3 is going to be a positive number. And if you track the vertex, for example, 0, 0 here moves to 0.30. So it looks as if the effect of 3 within parentheses on the basic parabola is to cause a horizontal shift to the right of 3 units. And we're going to, again, generalize this in a moment. So keep in mind the effect of h. So in this case, if h is positive, we're going to move to the right. H negative, we move to the left. Okay, and let me leave this one and go to the next page. In our next page, we're going to look at the graph of -2 times x plus 4 squared. This time, we have a number of effects going on with this one. Okay, and here's how we can actually look at the effects that going on with this one. First of all, we're going to take a look at the negative that's in front of 2. Remember, the negative will cause a reflection, right, about the x-axis. So it will flip the graph over the x-axis, right? That's what that does, the reflection about the x-axis. What you see here, again, the dotted line here, this one is the graph of -2x squared. So let me actually on my own graph the basic parabola here. Your basic parabola is going to go through these points. So this is what the basic parabola going to look like. -2, 4 was the other one, and that. And there you go. What I have here, this is the graph of x squared. Remember, that's your basic parabola. Now, what we do next is, in fact, with the -2. So the negative will cause a reflection, right? It will reflect the graph of the parabola. And then the 2, because it's a number, ignoring the negative. It's a number bigger than 1. So it will make the parabola narrower than the basic parabola, the one that I have up here. And then the effect of x plus 4 is to shift the parabola 1, 2, 3, 4 units to the left, right? In this case, this vertex is now here, -4. Now, the reason, again, it's negative is actually listed down here. You can see why it's negative. Because within parentheses, when we have x plus 4, we can write a +4 as double negative, right? These two double negatives right in here. These two make a positive. So once we think of it as x minus a number, now clearly here h is -4. And hence the movement, the shift to the left. Okay, and then we're going to summarize this finding now for the effect of h inside parentheses. And there you have it. So the graph of f of x equals a times x minus h squared. It's going to be the same. It's going to be the same as the graph of ax squared. Now, depending on h, if h is positive, the graph is shifted h units to the right, right? So we're going to have what we call a horizontal shift here. We're going to have a horizontal shift. That's what the effect of h is. We have horizontal. It looks like I can't get past the margin here, so let me just erase this one and just write it here. So we will have horizontal shift. That's the effect of h. If h is positive, the horizontal shift will be to the right, and if h is negative, the horizontal shift will be to the left. And of course the vertex is going to be at h. And finally, we get into part C of the section where we want the general graph of f of x equals ax minus h squared plus k. So if you notice now, piece by piece, we are adding on more bells and whistles to the graph of x squared, the basic parabola. We already saw the effect of a, we saw the effect of h, and lastly, we're going to take a look at the effect of k here. Okay. Now, for effect of k, I don't see an example that has just k in it. Well, actually, there is one, but I have an example of that in my own notes that I'll show you in a moment. Let me go to page 738. In fact, I may have it on that page. I'm not sure, but let's see on page 738. Okay, yeah, I don't have that, but I can actually do an example of that one. Let me see if I can go back here and graph one maybe. Yeah, I'll do one in my note for you, the effect of K. But what K will do here is the following. The effect of K is it will cause a vertical shift now. And that's what this is. If K, a number by itself away from parentheses, is positive, the graph will be shifted up K units. And if it's negative, it will be shifted down absolute value of K units. Because K could be positive or negative, so the case where K is negative, it's like if I say -2, down -2, that's kind of like double negative talk. So for that reason, we just say down 2, and that offsets the negative numbers for us. So, and the need for absolute value on K when K is negative. So remember, K positive, you go up. K negative, you go down by absolute value of K. Now the vertex is going to be at HK. The axis of symmetry will be at H. And if A is positive, the parabola opens upward. Otherwise, if it's negative, the parabola opens downward. Now here they mentioned that A positive, then the minimum is at K. And I can again show you these in the examples and clarify these for you. So I guess the next step is to actually take a look at the page of exercises, and I'll do some of these exercises for you in just a moment. Now, so that you can see, these are the exercises, begin on page 740. The exercises that you actually will be doing yourselves for the homework, it's on your homework sheet. But just to kind of show you, the exercises that you will be doing are number 7. So you're going to be doing this one, number 7. And then you're going to be doing number 19. You're going to be doing this one, number 19. And then on the following page, you do number 39. Let me X this out and go to the next page. On this page, this is page 741. I have you take a look at number 39. And there it is. Number 39 is this one right in here. And of course, I'm going to do also number 50. I'll do ones similar to the ones I just circled for you, and I'll also do number 50 for you. So let's take a look at these exercises. We're done with the pages of the book, and let me actually now go to my notebook. And here you go. So in section 11.6 again, what we would like to do is we would like to be able to graph this function f of x equals ax minus h squared plus k. Now, as far as the name of this, the form of the function, there are different various forms of a quadratic function. So I have directly beneath this one, I have the polynomial form, for example. And what we're looking at here is called, this one is called the vertex form. Then the one that's around is boxed around. This is called the vertex form, or the HK form. That's H hyphen K, not H minus K. That's just the HK form, where H and K are the coordinates of the vertex here. So maybe I'll write that. The vertex is going to be H comma K. Okay. Now, I'm going to start again doing these exercises using what we learned in this section, using the transformations. We're not going to plot any points, folks, okay? So, let's begin with exercise number 8. In exercise number 8, the function is f of x equals negative 3x squared. So what I've done here, I started with the basic parabola, right? X squared. And then the negative in front causes a reflection. So what I did next is I reflected it. And then I made it narrower than the basic parabola, remember? Because this number 3 is greater than 1. So A, which is the number in front, let me write that. For this exercise, A is negative 3. Okay, and because that number is negative, the parabola eventually is going to open downward. Again, that's what this negative in front is. Now, for all of these exercises, we want 3 things. We want the coordinates of the vertex, okay, the coordinates of the vertex. We want the equation for the axis of symmetry, which is this line here, the axis of symmetry. And we would like to have, oops, sorry, I didn't want to do that. No worries, let me redraw this one. No big deal. So f of x equal x squared, our basic parabola. It's going to look like this. Doesn't have to be exactly drawn by plotting points. Remember, the whole idea is to do this without plotting points. So this is the graph, the basic parabola. The axis of symmetry is going to be this line, the line that runs right through the vertex. Okay, its equation is going to be x equal h, in this case 0 for the basic parabola, because x squared could be written as x minus 0 squared. Okay, and that's what h is. There you go, that is what h is. Okay, and of course plus 0, and that's what k would be. This is the k part. That's just an elaborate form of x squared. Okay, now going back to number 8, the axis of symmetry is always going to be x equals. That's always going to be x equals, and then whatever the vertex, the h part of the vertex is. Remember, for exercise number 8, the vertex remains at 0, 0. So this 0 actually is the first 0. Maybe I use a different color. This one, because these two are indistinguishable zeros. Now they are distinguishable because I use color. So there you go. That's going to be the equation for the axis of symmetry. And then the maximum value is going to be 0. The maximum is the peak. In the case of a parabola opening down, the maximum is the highest point on the graph. There is no point higher than this point. And for maximum value or minimum, we look at the y values. Okay, keep that in mind, please. So we look at the y values, and y value is 0 in this case. There, that's the maximum. And for this exercise number 8, there is no minimum, because you can see the arrow, down arrow, means this thing goes indefinitely forever down. So some say minimum is negative infinity, but then again, that's not a number. So we're going to say there's no minimum. And we are done with this graph. Notice I did not plot any points, like let x be 2, y would be whatever. Let's take a look at exercise number 20, and that's this one right in here, number 20. In exercise number 20, the function f of x is given by negative x minus 1 squared. So what I have done is the following, and there you go. Here's this one. Again, the number before parentheses, that's what a is. A in this case is negative 1. So let me write that. A is negative 1, which is less than 0. So therefore, the parabola is going to open downward for a less than 0, right down here. You see that? If it's less than 0, the parabola opens downward. Otherwise, it's going to open upwards. That means otherwise means positive. It cannot be 0, by the way, because if it's 0, we don't have a quadratic equation. The x squared term becomes 0. So it can only be positive or negative, not 0. That is what a can be. Okay, so what did I do with this one? First, we always start with x squared, the basic parabola, and that's what I've done. So I have graphed the x squared. That was this one. So I started with this one. And then, because negative 1, h is 1, so we move to the right 1 unit. And the negative in front of parentheses. This negative in front of parentheses causes a reflection. So what I did is I reflected the graph, and that would be the graph of the function. Now, reading from the graph, the vertex is going to be at 1, 0, and that's what I have here, vertex 1, 0. Remember, the axis of symmetry is the line that runs through the vertex. The first component of the vertex, the h, is the equation of that. Remember, vertex was 1. Let me show you that one. See, vertex is 1. So the axis of symmetry is going to be 1. Whatever those turn out to be, these two numbers are always the same. Okay. And let's see, the maximum or the minimum, because the parabola opens downward. You see that? The parabola opens downward. So this parabola has a maximum, again, that happens at y value of 0. And minimum, there is no minimum. Minimum is none. Number 20, we're done with that one. Let's take a look at number 46. And this number 46 is very similar to number 39, actually, that you're doing. Number 46, g of x is 3/2, parentheses x plus 2 squared minus 1. So, again, just to point out, the form is x minus h. So if you have a positive here, think of that as double negative. So h is going to actually be -2. Right, because you can write this as negative of -2, and there's your h. H is -2, and that's what I did right next to that, as I rewrote it using double negative, this one. Now, here, the number in front is a. A is positive, so the parabola is going to open upwards. Now, just because you have a fraction, it doesn't mean that the parabola is going to be flat. If the fraction is less than 1, it will be flat. But if it's greater than 1, it would be narrow. So 3/2 is 1.5, which is bigger than 1, therefore it's going to be narrow. Right, it's not going to be flat. This parabola is going to be narrower than the basic parabola. And so what I did next is I found the coordinates of the vertex. Vertex is going to be at -2 and -1. How do we know that again? There you go. Remember, this is h, and I left out the k. K is -1 here, and that's what k is. Right here is k. All right. So we got the coordinates of the vertex, and next, so what I did as far as graphing was this. I started with the green parabola, the basic parabola. And then I moved it to the left 2 units, made it narrower than the basic parabola, because that 3/2 is 1.5, right? Because this number is 1.5, 3/2. So that makes it narrower than the basic parabola. And then the -1 here, actually, k -1, or right up here, these are the same. This -1 causes the parabola to go down 1 unit. And now the vertex is going to be located at -2 and -1. So those are the coordinates of the vertex right in here. But again, note I did not plot any points. I used transformation of the basic parabola. Now, as far as the 3 pieces of information we are interested, we want the vertex, which we found right in here. That was the vertex. And then we want to find the max or the minimum. Because the parabola opens upward, there is no point lower than -1, so the minimum is at minimum value is -1, and the maximum, there is no maximum, because again the parabola shoots up to the sky, so there is no maximum. The axis of symmetry is always going to be h, the first part of the vertex. Let me highlight it for you again right in here. Remember, vertex was -2. Look at this one. H is going to be -2. Those numbers will always be the same. And now we have the equation for the axis of symmetry also. Okay. And here I just made up an example for you. Again, this is very similar to the one you're doing number 39. Just to show you how you can do this. Notice how quickly, by the way, I'm able to graph these without plotting points. You always keep in mind, you always start with the basic parabola. So that's what this is. This is my basic parabola. That's x squared. We always start with that. Now, the -1/2. -1 half. A negative causes a reflection. A half makes it flatter than the basic parabola. So that's what I did next. Well, actually, what I did next was this. Because of this plus 5, I moved the parabola to the left. So there is a horizontal shift to the left 5 units. So I shifted the parabola to the left 5 units here. Okay, and there we have it. That's 5 on the left side. And then what I did is I reflected it. That's the green. So let me use blue. The blue curve here, this one. This one is x plus 5 squared. And then I reflected it with the green, and the green one is actually this one. This is the green parabola right in here. That's this one. And then because of negative 1/2, I made it flatter also. Okay. And let's see, plus 3. Oh, actually, let me see here. Plus 3. Yeah, sorry, let me just back up here. Okay. The blue parabola, this one, let me see, make sure. Yeah, that one is okay. I'm okay with that one, actually. You don't need to fix that. There you go. That's correct. Okay, after I drew the blue curve, I reflected it, and I drew the green curve. Okay, so that's what I did. And then finally, because of that 3, I lifted the parabola up 3 units. So actually, this red parabola is the function. Okay, this is the function, which is all of these. That's the answer to the problem. It's the red parabola. So it's going to be opening downward, flat, shifted left, and moved up 3 units. As far as how do you know which of these transformations to do first? Do I shift up first, reflect second, and this and that? How do I know which one to do first? What I do personally is I follow the order of operation. So I do what's in parentheses first. Okay, so that would be this part right in here. So you do the parentheses first. That means you shift left first. And then you do what's in front. That doesn't matter. You can reflect and flatten it, or flatten it and reflect it. Doesn't matter. And what I did after I shift left, again, I reflected it and I made it flatter. Okay. So I guess I could do this. This part, the reflection here, this one, is actually the part that is negative of x plus 5 squared. Okay, that's what that one is. And there you go, negative x plus 5 squared. That's just the reflection that I did. And then I made it flatter, that's the green, and then I moved it up. That gave me the red curve. Hopefully you can follow all that. Vertex ends up being at negative 5, 3. Maximum is at 3. There is no point higher than 3. The minimum, there is no minimum. Again, remember, because the parabola opens downward. And the axis of symmetry is going to be whatever the h is, right? So your axis of symmetry is going to be, yep, there you go, that number. And that will work this exercise for us. Okay. And with that, I believe we are done with this section. Hopefully you were able to follow all of that. But remember, we do not want to plot points, folks, in this section. We want to use what we called, again, let me write it. We use what we call transformations. That's what we did. Transformations. That is a movement to the right, to the left, up, down, and then you make it flat or narrow, and then possibly a reflection. Okay, everyone, hopefully again you were able to follow all of that stuff, and now you can do your exercises. Thank you for your attention, and here we go.